and everything. Great. So, hi, everyone. Actually, wait. We're in Sweden, so let me fix this. Whoops. Hey! Oh, we can do a little better than that. Come on. I'm going to need a little more energy. Hey, Stockholm. Hey. Thank you. I need some excitement because I'm a little bit nervous, but I'm also very excited to be here. As our lovely MCs mentioned, my name is Vaidehi. I come to you all the way from Portland, where I work at a company called Tilda. We build a profiling tool for Ruby and Rails apps called Skylight, and we also work on a bunch of open source projects, some of which you may have heard of, like Ember. An interesting thing about working at a company that does a lot of open source work is that many times you end up going down rabbit holes and you learn things that you didn't expect. Sometimes you learn about things you thought you already knew, and that actually happened to me pretty recently with JavaScript objects. Now, I always thought that I knew what a JavaScript object was, and maybe this applies to you too. If you've used JavaScript, you've probably been working with objects in lots of different ways. And they're everywhere. Most of the time when we think about JavaScript objects, we imagine something like this. So this is a pretty simple object. It's a cat. If you ever get bored in this presentation, just look at the cat and think of a cute little cat, and then it'll hopefully make you smile. But for a syntax that's so ubiquitous, many people, including me until recently, didn't really know the nitty-gritty of how the JavaScript object model really works. And a lot of the time, it's OK to not know that. But every once in a while, you run into a very weird bug, or you go down a rabbit hole, or you start looking at some source code, and it helps to know what's actually happening under the hood. And if you do that, you start to realize there's actually a whole lot more to learn. So today, I want to dig into a little bit about how the JavaScript object model really works, and some of the things that are hidden from view. So let's get started. JavaScript objects can be created with or without properties, but most objects will have properties set on them. So when we think about properties, we can sort of think of them as variables attached to objects. So we have our cat object, and nothing exciting is really happening right now. But if we add a property, like a sound property, and we assign it a value of meow, then things get more interesting. We can access or interface with an object and its properties in two different ways. So we can use dot notation, or we can use bracket notation. However, I said two different ways, but I'm actually lying a little bit because there are other ways to interface with our objects as well. We can interact with our object's properties by using property descriptors. I kind of want to play that animation again. But I'm going to run out of time if I do that. But there are a lot of fun animations, because I discovered that there's a whole bunch of animations I don't use in Keynote. So I went a little wild. So keep your eye out. But as it turns out, every JavaScript object comes built in with property descriptors. But what is this descriptor thing? Well, we can think of a property descriptor as the internal metadata that exists on every property on a JavaScript object. Every object with a property has a descriptor for that property. And the descriptor, as the name would suggest, describes the nature of that property itself. An interesting thing to note about property descriptors is that they are also just JavaScript objects, which is a little bit of a mind melt if you think about it too much, but we'll see this in action in a moment. Property descriptors give us a full picture into the object and each of its properties. We can sort of think of it as like peering under the hood to see what that descriptor really looks like. So let's take a look at this object and the property descriptor for sound. But how do we do that? Well, there are some handy-dandy methods that are built onto the object constructor API that let you peer into your object. So we can use object.getOwn property descriptor, and we just have to tell it, this is the object I want to look at, and this is the property. And if we do that, we'll look inside of the object. And it turns out objects don't just have properties as key-value pairs, they have this other thing inside of them too. And this is our property descriptor. So let's examine it a little further. This is pretty cool, but I don't know what all of this means. So let's take it step by step. As it turns out, when we created our sound property, internally, it was also created with this property descriptor. And this descriptor has 4 different keys on it: value, writable, enumerable, and configurable. Let's look at the first 2 more closely. Let's look at value and writable. The fact that our descriptor has these 2 keys is actually quite telling. What it's hinting to us is that the sound property is actually a data property. A data property is one that has some value, which may or may not be writable, which means we could or could not edit it, depending on what the writable value actually is. So the value on the data property could be anything that you can set on an object. It could be a string, a number, it could be another object, and it could also be another function. And this means that we could create our cat with a sound property that returns a function. If we remember what our original property descriptor looked like, we know that it has a value, and in this case, we've made the value a function, but we also know that it was writable. So that means we should be able to write to it. We should be able to edit it. So what would happen if we rewrote our data property using the assignment operator? Well, for one thing, we'd have a little bit rude cat, but I've heard cats can be a little rude sometimes, so that's not that surprising. No offense to any cat lovers in the audience. I like them too. But the interesting bit here is that we are able to reassign the property just because the descriptor told us that it was writable. So just by playing around with getOwn property descriptor so far, we've learned a few things about data properties. First, we know that we can access them and look at them by using the object API. We also know that there will always be a value on a data property descriptor, and it will also be writable. But what about getters and setters? Now, if you're not familiar with getters and setters, don't worry. They're not actually too complicated, and we can sort of do a quick whirlwind tour of how they work. In short, they're just a newer way of writing the same thing that we've been seeing so far with our cat object. So a long, long time ago, in 1999, JavaScript looked a little bit different. Specifically, the way that we define properties on classes was kind of different than it is today, especially if you're using ES6 now. So if we wanted to define a class back in ES3 and then add a function as a property to that class, we might have done something like this. We'll see that we're defining sound as a property with a function as the value. Now, we'll notice that this function isn't just returning a static string. It's doing some dynamic work. It's using this.name, and it's concatenating a string, which means that depending on what instance of this cat class you call this function on, you'll get a different value. But there was one really annoying aspect to this, which is that if you wanted to create a new instance of this class, like creating this new cat named Alfred, and then you wanted to call the property sound on it, if you just invoked it as though you were using dot notation, you wouldn't actually get the return value of the function. You'd get the function itself, which a lot of the times that's not what you're trying to do. You're trying to actually get the return value. So if you wanted to get the return value, you'd need to actually invoke it. Now, this actually isn't that terrible because it just looks like 2 parentheses, but if you have to type 2 extra parentheses all over your code base, like, you'd probably be a little irritated by this. But fast forward a decade or so, ES 5.1 comes out in 2011, and things changed a little bit. Notably, we got a new feature called getters and setters. And with getters and setters, we are able to rewrite our classes and their definitions to look like this. Now, instead of a property assigned to a function, we could use the get and set syntax to do kind of the same thing. But the payoff was pretty cool. It fixed that annoying problem we saw in ES3. In other words, we no longer had to invoke the property as though we were calling a function. We could just use dot syntax, and it just works. And that was pretty cool. So if we added a getter to our same object, we now know that even though it might behave like other properties that we've used, it's actually a special kind of function that will let us dynamically read or retrieve a value. And it'll also let us manipulate that value in some way. But we can use dot syntax to invoke it. And if we used a setter, it would set or write the value. It's worth noting that because a getter can retrieve dynamic values, this means that our getter could compute a different value every single time. The tricky part with getters is remembering that even though we invoke them just like we would a data property, there's no guarantee that they'll give us the same return value. So they kind of look like other properties, but keep in mind, they're a little different. And we'll see how this plays into our property descriptors in a few minutes. But speaking of property descriptors, we went on this tangent about getters and setters, but why? How does that tie into property descriptors? Well, when we look at the property descriptor for our cat, and we look at the descriptor for the getter that we just added to it, we see something slightly different. Notice that there's a get and a set key, but value and writable are nowhere to be found. Seems a little odd. Let's investigate. Well, even before digging into this any further, this won't be too surprising, because we just learned that getters and setters are inherently different from the other properties we looked at. So maybe it makes sense that their property descriptors also look a little different. The truth is, we're actually dealing with an inherently different kind of property here. This isn't any data property. This is an accessor property. Accessor properties come with a pair of getter-setter functions. And when we look at their descriptors, we don't see value and writable as the keys in their descriptors. Instead, accessor property descriptors have a set function, which is sort of the equivalent of the writable key we saw in the data property descriptor, and they have a get function, which is sort of equivalent to the value key we saw. And if we look back at our accessor property, we'll also notice that we don't actually have to set anything as the value of set. In fact, in this example, set is just undefined. We don't have to have a set key. We do, however, need to have a get key. Now, perhaps this makes more sense why we don't have value and writable in combination with set and get. Because if you imagine that we had both get and value, how would we know which one is going to give us the real data we're looking for? Is get going to give us the string, or is value going to give us the string? And if you think about it this way, it becomes a little bit easier to distinguish these two different types of property descriptors. So we have data properties, we have accessor properties. What do we do with this knowledge? Seems fine. Maybe you didn't know that, maybe you did, but how does that affect how you interact with your own JavaScript objects? The interesting thing is that we can modify and manipulate the way that an object behaves by understanding these keys, these property descriptors, and the keys that are in them. And we can sort of manipulate an object using the configuration of its descriptor. So there are two descriptor keys we haven't talked about yet: enumerable and configurable. And this is where things get a little exciting. These two keys are kind of special. We'll notice I've conveniently not talked about them, but they have existed on the data property descriptors and the accessor property descriptors. And the truth is they will show up on every property descriptor. Enumerable tells us whether the property that the descriptor is referring to is going to show up when we enumerate over that object's properties. For example, if a property descriptor's enumerable value is set to true, then that property will appear whenever we use it in a loop, or if we call object.keys on it. However, if the descriptor's enumerable value is set to false, it will not show up. And this will come into play in a bit. Configurable, on the other hand, tells us whether or not the property that the descriptor refers to can be modified, or if it can be deleted. And if a property descriptor has configurable set to false, then it definitely cannot be deleted. And it can't have its property descriptor changed again. So far, everything we've looked at has been enumerable true and configurable true. But as it turns out, maybe no surprises here, you can modify these as well. So by default, all objects, including the ones that we've made so far, have all been extensible. So what this means is that new properties could be added to our cat object, and we can change this functionality on a whole object basis or just on a property basis. We just had a very free way of adding things to that property. But maybe sometimes you don't want everybody to add anything they want. Maybe you want to limit the scope of your objects. Turns out you can do that. So for example, let's say that we don't want anyone to add anything to our object. We don't want them, or rather, we don't want anyone to remove anything or add anything to our object, but we do want them to keep writing to the properties if they were already writable. So in this case, we have a certain amount of limitation we want to do. We can call object.seal to achieve this. For example, if we sealed our cat object, then every property on this object would have its configurable property descriptor set to false, but we could still write to it. So this is the idea of being able to modify the value of something that was pre-existing, but I can't add to it and I can't remove from this object. But maybe we want to take it a step further. Maybe that's still too loosey-goosey for us. We want to be really strict with this object. Maybe we want to change our object so that no properties can be added or removed, and also you can't write to them either. Well, in this case, you can freeze the object by calling object.freeze. For example, if we froze our cat, not our cat, just our cat object. I do not advocate freezing cats. This is an ephemeral JavaScript object cat. But if we were to freeze this cat object, all the writable and configurable values on our property descriptors are now set to false. And we also wouldn't be able to change the value of this property, of the property sound anymore, because it's no longer writable. You'll note, though, that enumerable is still true, which means even though this property is frozen, it's still going to show up if you loop over it or if you call for the keys on this object. Now, there are a few things to know about freezing objects. First, if you freeze an object that has a getter, because getters can return dynamic values, there is no guarantee that the getter's value is going to be frozen. So that's a gotcha with getters. Secondly, earlier we learned that any object can have a value set to another object. That's totally valid. But if you freeze that object, you have to remember that you have to freeze the object that is the value of that property. In other words, if you freeze an object, don't just assume that any values that point to objects will also freeze. The object itself won't be frozen. You, as the developer, have to internally think about and take care of that. So that's another thing to think about, explicitly freezing objects within objects. So, finally, let's talk about enumerable. Most objects will inherit from a prototype, which is the parent constructor that every object inherits from. But when it comes to objects' properties, only an object's owned properties are enumerable. So this means that its parent prototype's properties are not enumerable. This might seem a little odd to think about, but if we look at an example, it might make a little more sense. For example, if we looked at all the property descriptors on an array, we would see that it has a parent prototype, which probably has properties on it, and it also has its own property, length, which is set to enumerable false. This is done for a very important reason. Every time you iterate through an array, you don't want length showing up. You want the actual properties, the values in that array. So it makes sense that enumerable is false for the length property. Similarly, you wouldn't want all of the properties on array's prototype to show up every time you loop through. That would be very frustrating, and it would be a very long loop. So there's a reason to sometimes make enumerable false. And if you talk to framework authors or people who work on libraries, this is the kind of thing that they have to think about a lot more than maybe we do, because they're dealing with legacy code bases, and they have to think about how they construct their objects and how it might impact someone else's code that consumes it. So, one last note I want to make is that so far I've been telling you to use the object constructor API. I like to use it when I'm playing around in the console, but really we should all just be using the reflect API. Reflect was introduced in ES 2015, and it provides a lot of methods that are similar to reflect, or to object, rather, but there are a few subtle differences, and it's important to use reflect now that it's a thing that exists in the latest version of JavaScript. And if you want to know how these two APIs are different and how their methods diverge from one another, you can check out this documentation that I wrote on MDN, which actually compares the different methods, including the ones that we've been using today, and their reflect counterparts. So, JavaScript objects have a lot going on. And I feel like I've said the word object like 100 times. So thank you for bearing with me. But hopefully, now we know a little bit more about the JavaScript object model and how it works. And hopefully, the next time you interact with a JavaScript object, you'll think back and realize that there's actually more happening under the hood than first meets the eye. It can be helpful to know that this exists, even if you don't have to use it on a day-to-day basis. And it might help you down the road. For example, learning about JavaScript objects and the object model was super helpful for me in order to understand some of the new proposals that have been coming out for TC39, which is the governance body for the JavaScript language. In order to understand some of those proposals, I realized I didn't know enough about the JavaScript object model, and so I went and dug into it, and now it's been super helpful, not just for learning new features, but also in debugging my own code and digging into source code, understanding the JS internals. It's really been eye-opening to me. and it's helped me see things in a way that I didn't before. But beyond JavaScript objects, if there's one thing I hope you take away from this talk, it's this. Don't be afraid to look under the hood to see how something works. I know sometimes it can be daunting, but even though it's a little intimidating, if you dig a little bit deeper and ask why and see where the rabbit hole leads, every once in a while you might notice that it'll make you feel really awesome and empowered and a little bit like this. And proving to yourself that you can learn new things makes you feel great, but it can also really help other people. If we learn new things and share them with others, well, that would be great for the community and great for us, and it would help a whole new generation of developers. And honestly, I can't really think of anything better than that. So thank you very much for letting me share the things that I learned with you today. You've been a wonderful audience. And if you really like learning new things, you might want to check out some of these projects that I've worked on. Maybe you'll find them useful. Thank you so much.